Hello everyone! Welcome to Field Trip Friday. Today, we're going to be talking about chemistry. Chemistry and chemists look at what things are made of. To start, we're going to think about what happens when we combine things. If we take a bunch of stuff and mix it together, we're either going to have a mixture or a solution. If the things we put together can be easily separated, that's a mixture. So think about trail mix. We can separate out the different components of a trail mix, which means it's a mixture. A solution, on the other hand, is something that can't be easily separated. So if you were to take salt and mix it into water, we can't take the salt back out of the water then, so that's a solution. I'm going to show you some examples of mixtures and solutions, and your job is to decide whether you think it's a solution or a mixture. For our first example, we're going to mix sugar and water. Let's see what happens when we put the sugar in the water. I'm going to mix it up. So I've mixed my sugar into the water. Am I going to be able to get that back out? No, that sugar's dissolved in the water. And since it's dissolved in the water, is it a mixture or a solution? It's a solution. For our next example, we're going to add oil to water and mix them together. Let's see what happens when we pour the oil into the water. Put the lid back on, and I'm just going to take my spoon so the oil and the water don't mix together. They stay separated. Even if I stir it up and mix them together, does the oil stay part of the water, or can we separate them? We can separate them. So does that mean it's a mixture or a solution? Oil and water is a mixture. Our next example might be a favorite of yours. We have a bowl of M&Ms. Do you think M&Ms are a mixture or a solution? M&Ms are a mixture. We can separate out the different colors of the M&Ms. Our last example is a little bit trickier. This is a bottle of carbonated water. If we give it a shake, you can see the air bubbles that are in there. Do you think carbonated water is a mixture or a solution? It's a solution. Sure, the air bubbles will rise out, but it'd be really hard for us to sit here and separate the water from the carbonation. In our mixtures and solutions, we saw examples of physical changes. A physical change is when something's physical properties, which could be how it looks or how it feels, changes, but what it is stays the same. So if you think about our sugar and our water, when our sugar dissolved into our water, it changed how it looked. But it was still sugar, and the water was still water. Nothing about what they were was different. On the other hand, we can have a chemical change. In a chemical change, we might see differences in physical properties, but it's also going to change what we have. It's going to turn one thing into something else. We're going to look at an example of a chemical change by doing an experiment. For this experiment, you're going to need a cup of warm milk, and I warmed mine up by putting it in the microwave for a little bit, so you can have an adult help you with that. You're also going to need 4 tablespoons of vinegar. I already have mine measured out. A spoon, a strainer, some paper towels, and I have an extra bowl just as something to strain it in. If you want to do it over your sink, that'll probably be much easier. I'm going to start by just taking my vinegar and pouring it into my milk. I'm going to do it a little bit at a time. Sorry, my dog is pushing the table. All right. The next step is to just mix it up. And as you mix it, you'll notice that you see lumps forming from your milk. So what's happening here as I mix my vinegar with my milk is the acid from the vinegar and a protein in the milk don't mix together. So that protein is separating out. So I've done a pretty good job of mixing it. And now I'm going to take my strainer, and I hope you have a bigger strainer than I do. Mine's very small. And I'm just going to carefully pour this through my strainer. Now I'm going to use my spoon to kind of help press some of the extra liquid out. Your goal here, you want to try to get it as dry as you can. Okay, I'm going to leave that on my bowl for right now. I'm going to put these aside because I don't need them anymore. I'm going to take out some paper towels because it looks like it's pretty dry. But I'm going to use these paper towels to dry it even more. So I'm just going to scoop this out. I'm just going to dry it with my paper towels. Pretty gentle with it. And be careful while you're doing this stuff because it might still be warm. Mine's still warm, but it's not hot. So now what we have forming here is kind of like a soft clay. Mine's still got a good bit of liquid left in it, so I'm gonna keep squeezing it. So now that I've gotten most of the moisture out, I'm just going to knead it for a little bit to make it nice and smooth. Now that this is nice and smooth from kneading it, not only have we caused a chemical reaction by adding vinegar to milk, but we've also created something we can use like clay. So you can take your ball and sculpt it into whatever you want, let it harden for a few days, and then you can paint it or color on it if you like. So have fun making your chemical reaction and doing your art project, and we'll see you again soon for Field Trip Friday.